In this video, we want to solve the polynomial inequality f of x is less than 0 for the function x plus 1 quantity squared times x minus 3. So what is this really asking us? We're asked, where is this function less than, strictly less than 0? So what this less than 0 means is we want to know, where is this graph negative? Where is it negative? So if you think about where a graph is negative, or how we get to a negative portion of a graph, the only time that we can go from a positive to a negative is at a 0, by crossing through a 0. So if we can find the zeros of this and then test values on either side of the 0, then that will give us a sense of what's happening over those intervals. So that's what we're going to do. We're going to look at the zeros of this polynomial function and then test points on the intervals. So we know that from this factor, we get, by setting it equal to 0, we get a 0 of -1. And then from this factor, right, when we set that equal to 0, we get a 0 of +3. So we have zeros at -1 and +3. So if we draw a number line here, and we put -1 here and +3 here, we can then pick values in between these, and then values to the left of -1, values to the right of 3, to test their values by plugging them into this, and then whatever their sign is, that's going to be the value, the sign of all values to the left of on that interval. It's going to be the sign of all values on that interval. So let's start with -2. So what is f of -2? So if I'm over here at -2, what's going to happen? So plug -2 into your function. So we have -2 plus 1 quantity squared times -2 minus 3. So that's going to be -1 squared times -5. -1 squared is just +1. +1 times -5 is -5, which means the values on the interval to the left of -1 for this polynomial are negative. We've done this before, this interval testing. We did it back when we talked about inequalities with polynomials that were just quadratics. So these are just a little higher degree polynomial function. So now let's test the interval between -1 and 3. So a good value to pick there is probably 0. So what is f of 0? So we have 0 plus 1 quantity squared times 0 minus 3. That's just 1 squared. And then times -3. 1 squared is 1. 1 times -3 is -3. So again, on the interval from -1 to 3, we have a negative value. And then a value to the right of 3, sure, let's say 4. Plug in 4. So we have 4 plus 1 quantity squared times 4 minus 3. 4 plus 1, that's 5. So we have 5 squared times 1, which is 25 times 1, which is just 25. And that is positive. It's positive there. So again, what was our question asking us originally? We wanted to know, where is our graph less than 0? Where is it negative? Well, we know that it equals 0. It's equal to 0 at -1 and at 3. So because this is not less than or equal to, these are not included in either of our solutions. But we do know that any value to the left of -1 is going to give us a y value that's negative. So all of these values, x values to the left of -1, are going to be part of our solution. But at -1, it's not included, so we use parentheses here. And then we say that it's everything to the left of -1. So in interval notation, that's from -infinity up to -1. And we use parentheses at -1. We can see that here we have a negative interval in between -1 and 3. And for the same reasoning, we know that we have parentheses at -1 and parentheses at 3, because that's where our graph is equal to 0 And we're not asking where it's equal, we're just asking where it's less than. So we have this here and here, parentheses there, and then it's any of the values in between it there. So that's from -1 to 3, again using parentheses. So that's our solution in interval notation. If you were looking at it in set notation, it would be the set of all x such that x is less than -1, or x is in between -1 and 3. So -1 is less than x is less than 3. So this right here is our solution.